Hello guys. So in 6 of our TensorFlow play series, where we'll column, and this is by far the most important topic of TensorFlow, because in tutorial you will learn how to apply your columns for uh, basic TensorFlow database modeling, so that you can have that dictionary of features as well as your target, and you can understand how to fed details into your Keras model corresponding, right? So in this tutorial, the outcome will not be on the accuracy of model, but the structure and the process how to implement your columns based, right? Side tensor tutorial one. So in version, everything will remain your calling API. I think now goes side Keras module. Have to use function call for have to use Keras module. Okay, so let's get started. So you can like what are the corresponding tasks here that we perform. First, we'll load a C file using as tool, and for this we have done in a CS file load here, then your out of memory. But for TensorFlow using TF records and TF data module, right? That we can just do everything. Now, next thing will be your building of your data pipeline that will probably contain some batch coupling. Once that is done, map, mapping various columns, the CSVs that we are going to train the model, and we'll finally a very basic classifier model structured data set using. So for this tutorial, we're going to find it little detail about this, that it has columns. Uh, Columns you have type as column, type of dog or cat. For the animal have age categorization, for the animal the breed, first primary size, full length, that the cat is or animal is dead or not, realized on the health condition cat and dog, is there any adoption period for that particular person. Then lot of photos uploaded, different social sites for adoption, finally the adoption. And from this adoption speed, first we'll create one classification target. Once the target is ready, we will see how to implement if.feature column tool for building your machine. Okay. So first necessary imports, import numpy as for your new processing, as for data manipulation as it's right. Then where TensorFlow basic backbone. Then for from TensorFlow will be column. Case to focus will be the standing column. Then from TensorFlow.keras we import layers for your from scikit-learn model train test split. So this one is required for your train validation and test set preparation from the whole data set. Okay, so let's just quick put all of this for our requirement done. Let us just cross verify that the version of the got some. So our models are loaded. Right? Now, first thing, we, uh, for any data science project or deep learning project, right? Your data import. So the dataset URL, our data resides on Google Cloud, Google Cloud Storage, where our data resides. Finder file, so file. This is the CSV file, that data set. How you can file. So Keras has a beauty get file. Get file, you have to pass the file name, URL of the data set. Then whether it's a zip or direct file. So for zip, extract, and extract equals to where you want to cache the direct point, right? So this is the utility total with parameters required for your file utility. Once your file is available in the local folder, then you can load it. Dot read, right? I mentioned our cache dot the root. So yeah, once it is done, our data frame is loaded. We can visualize the data using head method. So you can see whatever columns we have mentioned, right? Is here. So type is the first column, has and dog, as age is a monochromatic. Uh, so the age 1 2 4, it's I think bucketization here. So then again in all the that you can the genders, color, size, full length, did no or not sure or whatever, right? Then serialized, health, description, photo amount, adoptions, right? All the things that we by that age, photo amount, and adoption speed are the big columns of this data set, right? First thing is creation of the target variable, as you have already mentioned, going to be a classification problem, but our target here is to more importance to understand this column rather than your but accuracy of model, highly accurate classification, right? So will important to all of this, but for working sake, so our data frame has target column, right? Have to so our target column will be where clause, where you will find the adoption score. Then based on the data that it is not adopted, rest of all the codes. Once that is done, can definitely that options description, as you are not performing any task here to, let's say, classify doing sentiment analysis. That sentiment, that's it. Probably for higher point of time. All of this right now, but so what we can do, drop this adoption. We utilize this, build our target column. Okay. So what you have learned so far: use of NP-wire for closing purpose, sales purpose, price data set. Second one is get file utility of Keras. But so once it is done, we have to do split data frame, train, validation, and test. So first, what we will do, we will first split the data set, the whole data set as training and testing data. For that, we will learn model selection. From there, train, test, split method. So train, test, split method will have the data set, the whole data set, buying 80% in training, percent in. Once that is done, we will have a train data set corresponding of 80% data of the whole data. Once that is available, again we will split the train data into train data and validation data. 80% of the available data in train So finally your train data will have 84%, right? 4% data belongs to training data, percent of data belongs to validation, percent data belongs to testing data, right? So once you run this cell, it's the job. So you can 7,400 approximate is a train example. Validation contains approximately 1,900 of example, 1,300 of examples are in test data. So let's wait and you just understand so far whatever we have done will be. So yeah, now as the your main part will start and your main part will be creation of input pipeline using data. So as we have mentioned, right, this tutorial is complete their columns. Now using their columns with various data pipeline. That data pipeline will get into the model, then we'll get prediction. So first thing, data, whatever we are going to build, we'll create a utility method that that will create a data set from a pandas data. So currently, remember whatever we having in this data frame object is the pandas data frame object, right? So our first target converting this data frame to a data set or instance, right? So you see inside this function, it is nothing but first what we are doing a copy, not a deep copy, we are shallow copy of this data frame, pandas data frame. Once that is done, we are popping up the labels from the data frame. As we already know, target is the example uh, output channel basically or output column of this data frame. We are popping up that in the very next line. And in the third line, as I have already mentioned, right, this data has very less of data, near about 7,000 data. So we can from tensor slices this method of tf_data.dataset module. So we are using from tensor slices method create one data set out of this as data. And for this, you require the data frame to be passed as a dictionary. DICT dialog or method for and from a data frame you are passing the level, right? So this dictionary of data frame get the features, the levels, okay, and in that manner get data set. Once this instance is ready, so for training we probably required to do a shuffling. For testing and validation we don't require any shuffling, right? Why we require shuffling in of training? To break any kind of ordering if present in the data set, right? So that is the clause we have added. If shuffle, that means it's a training data set basic shuffling, then your DS data set in dot shuffle, and in buffer size we have to pass the total length of the data, which is our case 1000, right? And once the shuffling is done for training data set, for rest of all the data set, what will do a batching process, right? So then your ds will equals to dot batch, and in the batch we'll pass batch size, which is but by default 32. You can change anything, right? Then we are simply returning the data set. So what is the output of this in this bed, the pandas data frame, and the output will be df.data.data. Okay, so once that is output is generated, you can see the details later point of time by calling this function, right? So one thing just I want to share is the dictionary of data frame. What will happen if you put dictionary data frame? I'm just currently target, right? I'm calling the method on data frame. You can see your comma key and rest of the value uh, indexes, right? The whole index, I think 1500 uh, is from a value, right? Health is from one key. So data frame call health, you can see all the values, right? Likewise, you will see nothing but a pandas dictionary, right? All the data. So what happens here? You are passing a corresponding, right, dictionary of the data frame and corresponding. Always remember you are passing the without the labels. Have already in the previous line popped. So yeah, it is done for a simple explanation. Now what we are going to do here, we are going to do batching on data set, training data, validation data, and for explanation purpose, we are keeping the batch size to by default the batch size is 32, but for explanation kept here the batch size as, so that what output it will generate, all this one, what output it will understand the process, right? How inside TensorFlow models you have to pass feature columns. Okay, so now it is ready. Your train data set is ready, validation ready, and data set is now. What we are going to do, we are going to run a for loop. So your train DS, nothing but what is your train DS? To understanding, train DS nothing but an instance of data dot data set, right? So once you keep that in mind, or once you nothing but a instance, what you can do, you perform all sort of operation that is possible on top of this data. That means dot take method you can is applicable on top of it for operation as this dataset instance is variable, but a iterable object in Python. So same thing, dot take method where we're passing one element. To remember previous size of 3, one element have 3 instances or 3 elements per batch, right? First batch elements. So what we are fetching, to remember how we batch or how we create it, pass the dictionary of data frame and corresponding levels, right? Of data frame is nothing but our feature batch, level batch. Okay, so we are having this feature and we are, right. So for what we are fetching from feature batch, we are taking nothing but a dictionary. We are fetching the key, a list operation on top of it, so that we can have list of all the keys. That means all the feature names available with us. Then whatever we have passed, that means inside the list, nothing but have a, have type, we have content, that level we have target, right? So that's the same thing we try to here. So a batch of ages, that means how you can fetch the batch, ready? Then you pass the ages. How you used to pass a dictionary, fetch the values from the dictionary, right? So can you tell me, if I run all of this, how many I mean elements I can see per take? 3 elements per take, right? So our batch size is, right, on the code that we have written. So our data set will output the data set per batch, right? Same thing here. Now if you run this one for every feature, then you can see nothing but your, you can see all this feature list has been populated here. Second one, for a here, you can see values, first batches. Okay, the first batch with the elements, right? can verify, cross verify shape here. For color one also, format the data type is by the shape. For color 2, same thing. For targets also, you can verify number of instance as well as shape and data, right? So this is what inside your data set contains. So this is how your data set organize itself generally for your flow modeling, right? Now on top of this data set that we have just created, we perform feature column creation. Once our feature columns has been created already, we'll feed that feature column in the TensorFlow model for prediction. Okay, till now we have understood. Now if you just change the batch size to normal 16 or 32, you will see these levels of values per batch, right? Which is pretty obvious. So if you that the batch of age, you can verify there is, right? Now because per batch you have 60, so that's how easy you can decrease amounts per batch or element, right? So till now it is clear, right? So we have created a tf.data.dataset instance. On top of that instance, perform various kind of batching operation, and if it's a training data, we will also perform some shuffling on top of it, right? So it's nothing but a dataset to dataset transformation. Okay, and as it's iterated iterable what can I data structure basically, right? You can also use here and next method, like it's a Python object, have verify the value, right? In ds can verify as we, and the batch size, first batch contain one by batch. Okay, let's move forward. We have created one utility called demo, where we are passing the column. Okay, so what would create a dense feature layer, basically create the feature that will be fed into the model, and have created this demo function for the visualization. So how your feature should look like when it fits into a TensorFlow model. So once this feature layer is created, you layers from where we have taken the layers, we have taken the layers from tf.keras utility, right? So once this dense features got created, we can print out them example batch, just doing calling the numpy operation so that it can in a numpy format. For let's say numeric column, go in top right, find this photo amount as new, right? Very basic of all the columns. Just pass this one feature column dot new. Okay, so we have tf dot feature column, right? We have already column as part of from tensor, right? Column, or else you can always call tf dot column. Then in feature column, we are again calling the numeric column method. And column we are passing photo amount by saying that okay, this photo amount column is the numeric column. So once it is registered as a numeric column, let's call this utility method and transform a batch of data. Call this, yes, done here. Target here. Now if you call the output, you get the error, right? So in the example value, what happens? Example batch, right? Instead of this features, we are passing the targets. That's why it happens, right? Now what happens? You are creating a photo count as your feature column, which column, and then you are passing your photo count new feature column to this demo function. Now you come to this demo function, which takes column. It's a layers dot dense feature, and it passes this feature column, which photo amount, that this one it will pass, right? Value it will pass, and once it is passed, what it will do, it will print the feature layer, and in with this example batch you have already mentioned here one. So 16 values, right? This example batch from here, then it will call on top of it the numpy operation, print it as a numpy array, right? That's what you are seeing the output. So this is how your feature columns will fed the model, right? For that purpose only we have created function, but it's straightforward, only it calling the dense. Okay, now let's move on. So you have understood what's a new column, right? Now we'll move to bucketized column, how to create a bucketized column. Okay, and we'll call this demo function to just visualize how that looks like. Now let's say I have age, the numeric column, right? Let's create this age as a bucketized column, right? Boundary. How we are creating the bucketized column for age? We are setting the boundaries. So okay, get four values boundaries. Okay, if the age is less than 1, then we'll create one boundary or one value. The age is between 1 and get another value. The age is than 5, it will get another value. The age is greater than 5, it will get another value. Okay, so for these three boundaries, the age bucket will create four values. Okay, that means age can hardly have four set of bucketing. Once that is created, what we are calling this bucketized column on top of uh, my numeric column. So we are passing new column to this bucketized column, and we are calling feature column for creation of this bucketized column. You got it? Then for visualization, we are calling this function, but calling this layer dot dense feature, and then so if you call this one age value something like this, example have 4, have 3, have 4, right? Are uh, 4 is your greater than 3 and less than 5, right? Also greater than equals to 3, 5, right? 4 is again that format, your age got transformed into a bucketized column. From numeric value created a bucketed value, right? Now the third one is categorical columns. So you will also have values that will have categorical columns, and you want to create, let's say, want to fit those categorical columns. So what you the scalars will create one hot vectors out of those categorical columns, right? For doing that, I think p dot categorical is the option, right? So same thing can do in TensorFlow as well, using the columns. You have to call categorical column with vocabulary list, or if you have those vocabulary files already, you can call categorical column with vocabulary file and pass the file. So we don't have any file here, we have vocabulary list here. So we are passing this type column as a column name, and with type column we are passing the unique values of type, which is cat and dog. So once you will pass animal type, it will get okay. First it will category column with vocabulary list. Once that is done, you again call feature column, and pass this method indicator column to create it as an indicator column. Call this demo method and visualize the output. See? So let's say it's the first one is cat, right? First one is cat. For cat it becomes 10, for dog it becomes 210. For cats, got it? So in this format you have transformed your categorical columns with vocabulary as a feature column, indicator column. You pass it to the tense feature, okay, the model. You directly embed this format to the model. Now if you have more than good number of categories inside your categorical columns, then what you will do, it embedding columns, the one hot encode, right? Because perhaps somehow your one hot encoding value not work very well with works, but your embedding columns performs very well with works. So how your embedding columns creates it, learn new while at the time of training with the mapping, right? Basically your input and output, right? So how to create? Same method, feature column. You have to call categorical column with vocabulary list. Once your categorical column with vocabulary feature column is created, pass this. Uh, Previously you pass as an indicator column, right? Here pass as an column. Here you will pass as an M. That's it. Mention the dimension. How to choose dimension? Probably square root basically of your total number of dimensions. Here the dimension, okay, probably okay, I don't know. It's only for demo purpose, or the number of breed embedding, how you're like, and this value instead of breed, machine or your model will get this value for prediction. Okay, now next one is hashed feature column. So as you have seen, you can do embedding, can do one hot encoding, you can also do hashing with your categorical column with hash buckets. So same method, feature column dot categorical column with hash bucket, have categorical columns with vocabulary list, and now in this of categorical columns with vocabulary list, pass categorical columns with hash bucket. Okay, hash bucket, you mention the bucket size because yeah, definitely to limit out the number of potential output the hash function will generate, right? And there same, to pass the function first. Once it is created, your hashing completed, call this integer column and pass it, pass the hashed column with the output. It also be like your one hot encoded value, but it use the hash function generate all this categorization or all the output. I mentioned the hash bucket sizes, whatever uh, the number of rows, or here the batch size is, right? So 60 cross 10 times of here. Now next is crossed feature columns. So crossed feature columns are very important to generate newer types of columns based on the existing columns. So how you can create? Same method, within feature column you have to call this crossed columns. Basically what you call categorical columns with hash buckets, or column with vocabulary list, and here you will pass crossed columns. For crossed columns you will pass the number the column details. Let's say age bucket and any type I want to do a cross, I want to variable out of it. So I'll pass this, and I'll pass the maximum hash bucket size. Here I'm limiting to 10, so that you need not to generate all kind of possibilities, right? So the hash bucket size will take care of this hashing automatically. Once you get the cross feature, then again you call an indicator column. Inside this indicator column you pass the cross features, will it, or it will the output of the feature column, and you remember this output get fed the model for training purpose. Okay, so these many options are there in TensorFlow for feature column purposes. You have cross feature columns, you have hashed columns, you have embedding columns, you have categorical columns, you have bucketized columns, you have numeric, right? So there are, I think, many more column options available. But for I think learn about all of these things, seven well enough to starting point, right? So now how to choose columns to use. So let's say I am choosing amount, fee and age. These columns want to pass it. So what I will do in the fee columns, I will append those as a numeric column, right? So how to use one have already seen, right? So what we have to call, feature column dot numeric column, and we have to pass the value of the right data set automatically. Same thing we are happening. We are appending column dot numeric column, and inside numeric column we are passing this. So it will create this feature columns inside this. Once this is done, then we have one bucketized column on the edge. On the edge, we are creating boundaries. Bucketized column contain 5, 6 number of inside this bucketized column. Second one is done. Third one is column with your categorical variables. So type, we have color one, we have gender, we have size, we have vaccinated, size, health. All this categorical column with vocabulary list we are passing. Now we have categorical columns, column dot categorical column vocabulary, and in the list we are passing dynamic column name, and by calling the that it all the inside the training data. Once that is done, we have column from this column. Once that is done, then we are again creating one embedded column from, then we are creating one cross column from age bucket and animal bucket, the hash bucket side, the maximum limit. Okay, and for showing purpose, we have the hash bucket as 10, right? Now instead of 10, so will become size of 100. So once everything is done, now what we have to create finally, as we have the demo function, right? We have to dense feature. So that's what we are calling this layers module from Keras, and from this layers module we are calling this dense feature. We are passing feature columns, get a dense feature vector, so that we can get value the machine learning model or deep learning model. So once this feature is done, our feature column is layer is ready. Once it is ready, we are creating using batch size of 32 for creation of this training station and set. Once that is ready, then we'll the model first. What in case of machine learning of CNN or any layer, what you used to pass, we used to pass the value. For CNN, I guess we pass the convolution layer, right? For normal deep learning DNN, we pass the image, but as a flatten method. But here, as we are doing SB, I think flat structure, flat file, what classification, right? So we don't need to do all of that. We pass this feature layer as it is. We are passing the feature layer as an input, and then we'll create a hidden layer of 120 ReLU activation, in another hidden layer of 120 of ReLU activation, control the regularization or to control the overfitting 10% of dropout. Final layer is nothing but a classification. So we are passing a dense layer with one layer of unit. The output of probability, I mean adopted, not adopted. Once the model is ready, we are doing a compilation to mandate parameters that we need to pass, that we have discussed in the very first optimizer, second loss. And once this were passed, we are passing optional parameter as because by default is loss. So if you pass accuracy, get both loss and accuracy in the output or in the verbosis. Once your model is compiled, a model.summary, you can directly call the model. So I'm calling the model here, model.fit. We're passing train ds, training data set, and for validation data we are passing validation data set, training for 10 epoch. So I have already trained that. Okay. You can also use callbacks to stop your training loss is not going down significantly or accuracy coming up, right? So you can cost or time have already discussed. So once the training is complete, training is have accuracy on training data around 76%, on validation 3%. Is kind of okay for this kind of data where we don't have much more data. So training, I don't think much better in this rather than for random forest or this. Well, once that is done, we are using our test data for model for evaluation purpose. Our model is performing at approximately 5% of accuracy testing data as well. So that's it for this tutorial. I hope you have learned all the required features, how to create a feature, basically how to create a feature column or indicator column and categorical column with vocabulary, column with hashing, column with for bucketized columns. All these techniques I've learned how to pass this by creating dense by calling your f.layers dot dense feature, right? Right? There how to create, then how to pass all of this for machine model for create work and how to train. Okay, I will see you guys in tutorial of another topic. And